Good day to all. Today we are going to see about that load equalization. From this word we can find out the equalization of that load. The load equalization is the process of smoothing the fluctuating load. If the load is fluctuating, then we have to have a smoothing of load. That will have that load equalization. Then the fluctuate load draws heavy current from the supply during the peak interval and also cause a large voltage drop in the system due to which the equipment may get damaged. See, if it is the voltage doesn't have a load equalization, then this may have a heavy current from the supply. It will have a heavy current from the supply side. Then it may cause us to have a large voltage drop, as well as this will tend to damage the particular equipment. So load equalization is a very important one. And in load equalization, the energy is stored at light load, and this energy is utilized when the peak load occurs. Thus the electrical power from the supply remains constant. Then the load fluctuation mostly occurs in some of the drives. For example, in pressing a machine, a large torque is required for a short duration. These are all the time will have the causes of that load fluctuation. If it is needed the large load torque in that short duration, as well as pressing that particular machine, we will cause to the load fluctuations. Otherwise, the torque is zero. Some other the examples are for this load fluctuations are in rolling mill and reciprocating pump, planing machines and electrical hammer, etc. Then in electrical drives, the load fluctuation occurs in the wide range. For supplying the peak torque demand to electrical drives, the motor should have a high ratings, and also the motor will draw pulse current from the supply. The amplitude of pulse current gives rise to a line voltage fluctuation which affected the other load connected to the line. Then this load equation, the problem of load fluctuation can be overcome by using the flywheel. With the help of that flywheel, we will overcome this load fluctuations. The flywheel is mounted on a motor shaft in non-reversible drives. It won't be reversible. That is the thing here, non-reversible drives. This flywheel is mounted with that motor. In variable speed and reversible drive, the flywheel cannot be mounted on the motor shaft as it will increase the transient time of the drive. Then if the motor is fed from the motor generator set, then the flywheel mounted on the motor generator shaft, and hence the equalizes of the load on the source but not load on the motors. The thing is, previously we will see in that motor it will mounted on the motor shaft, but here if it is the motor is fed from the motor generator set, then the flywheel mounted on a motor generator shaft. Because of this, the load source, the equalizations of the load on the source only, but not load on the motor. Then when the load is light, the flywheel accelerate and store the excess energy drawn from the supply. During the peak load, the flying wheel decelerates and supply the stored energy to the load along with the supply energy. Hence, the power remains constant and the load demand is reduced. See, the moment of inertia of the flying wheel is required for the log equalization, which is calculated as follows. If we consider the linear motor speed torque curve for Wm equal to omega m naught minus omega m r divided by Tr into T. Here assume the response of the motor is slow due to large inertia, and hence the applicable for a transient operation. Differentiate the equation 1 and multiply both sides by the j for that moment of inertia. So we will multiply the j with the both terms, so it will become j d omega m by dt, which is equal to j omega m naught minus omega mr divided by rt into dt. This is equation number 2. Then j omega m divided by omega t, which is equal to minus tm into dt by dt. This is equation number 3. Then the tm will have d omega m minus omega r divided by tr. If you are substituting this value over here, we'll see this the equation 3 and 2. We will substitute over here. Because of this minus tm by dt, we will keep here. Then this t by dt will get cancelled. Then tm will remain there. Then tm will have a omega m minus omega r divided by tr. That will come like the final equation of this two equation 2 and 3. So we will get this tm because we will substitute this value over here. Substitute the equation 3 into, we will get this equation number 4. Then the t mt t divided by tl plus t equal to tl. Consider a periodic load torque cycle which consists of the high load period with torque TLH and duration the one light load period with torque T2 and the duration TL, which is TLHS into 1 minus e to the power of minus t by tau m plus t maximum to the power of minus t by tau m. Here the t is 0 less than or equal to, it is less than or equal to th. The time limit for t is 0 to th. Then the t maximum is t LHS into 1 minus e to the power of minus t by tau m plus t max e to the power of minus t by tau m, where t equal to t dash equal to t minus th. Here the t minimum is equal to t into 1 minus e to the power of minus t by tau m plus t maximum e to the power of minus t by tau m. Here the tau m equal to th log e into tlh minus t minimum divided by tls minus t maximum. So j equal to tr divided by omega m naught minus omega m r into th divided by log e into tlh minus t minimum divided by TLH minus T maximum. Therefore, tau m is equal to T1 divided by log E TLH minus T minimum divided by TLH by minus T maximum. See the determination of motor power rating for the continuous duty. Here we will see the continuous duty determination of power rating. The first point is for that power rating, the maximum TS of power demand of that load is accentrated. A motor which next higher power rating from the commercially available rating is selected. Then the motor speed should also matches with that load speed requirements. And it is also necessary to check whether the motor can fulfill starting torque requirements and continue to drive load in the phase of normal disturbances in power supply system. The latter is generally assured by the transient and steady state reserve torque capacity of the motor. These are all the way to determination of power rating for that continuous duty. Thank you.